Hello, mathematicians. Today we're going to be learning about proportional and non-proportional relationships using tables. So here we have the relationship between the number of months and our gym membership. So the number of months is represented by X and our gym membership is represented by Y. As we notice on our table, our X increases by 1. If we take a look at our Y values, we notice that increases by 20. So here we could see that for every time our month increases, the cost that we pay for the membership also increases by $20. So at 0 months, we pay $0. And after 1 month, we pay $20, 2 months, $40, and so on. So I'm going to represent the gym membership and the number of months using rates. So for the first month, our gym membership is $20. So we're going to pay $20 for that 1 month. So after 2 months, our gym membership is $40. So $40 for 2 months. After 3 months, it's $60. So $60 for 3 months. After 4 months, it's $80. After 5 months, it's $100. And after 6 months, it's $120. So $20 for 1 month is already a unit rate, so I don't need to simplify that. But if I simplified $40 over 2 months, that would simplify to $20 a month. So these two rates are equal. And if I simplified $60 for 3 months, that would be also $20 a month. So that would make that rate equivalent. $80 for 4 months would also simplify to $20 a month. So that would also be equivalent. $100 for 5 months would simplify to $20 each month. So our rate is equivalent. And $120 in 6 months would also simplify to $20 a month. So that would also be equivalent. So all our rates here are equivalent, making this a proportional relationship. So because all our rates are equivalent, this makes this table proportional. So I'm just going to erase this. So we know that we pay $20 a month, and we could represent that using an equation. And that equation would be y equals 20x. And what this represents is, since we're paying $20 a month and X is the number of months, if we want to find the gym membership for any number of months, we would only have to substitute the X. So if I wanted to know after 4 months y would equal to 20 times 4. And so we could find the gym membership for any number of months. And the same is true that we could find out, if we knew the cost, how many months we would have membership for. So 20 here represents our constant of proportionality. And other words that can be used to describe the 20 would be rate of change, because every month that we increase, the membership increases also by the same amount, which is $20. So the rate which this table is increasing, so rate of change. And then another word we could use to describe it is slope, which is the same thing as the rate of change. So this table is proportional. And we know that because all our rates are equivalent. So here we have another table also representing the relationship between the number of months and the gym membership. The only difference here is that our gym membership has an initial starting value. So what that means is, before we join the gym, we're going to pay this initial fee of $50, and then we're going to pay a monthly fee. So even though we have an initial fee of $50, as the months increase by 1, we'll notice that the gym membership increases by the same amount, because the cost per month is still the same, with the exception that we have this initial fee. All right, so even though we could tell here using our table that we're paying $10 in addition to our initial fee every month, after the first month we're paying $60, which is including the initial fee and the cost per month. So I'm going to write down that rate. So $60 is the amount we pay after 1 month. After 2 months, we pay $70. After 3 months, we pay $80. So after 4 months, we pay $90. So after 5 months, we pay $100. And then after 6 months, we pay $110. So here for the 1 month, I don't need to simplify that since it's already simplified. But for the 2 months, if we divide the cost, so $70 divided by 2 months, we end up with 2 months costing $35 per month. For the $80, if we divide 80 by 3, we end up with a cost of $26.67 per month within those 3 months. For the $90 in 4 months, if we divide that, we end up with $22.50 per month for those 4 months. And here for the $100 in 5 months, if we divide 100 divided by 5, we end up with $20 per month for those 5 months. And then finally, if we divide 110 divided by the 6 months, we end up with $18.33 per month each month. So we notice here that because we had an initial value of $50, the longer we have this membership, you're dividing it amongst the months that you have. So this is not a proportional relationship because for the first month you pay $60. The second month, if you divide the cost of $70 among the 2 months, it ends up being $35 per month. For the 3 months, if you divide the $80 divided by the 3 months, you end up with $26.67 per month. And the longer you stay with this membership, the cheaper it is because you're dividing that initial cost by the months that you've been there. But regardless, it's not the same rate. Therefore, this is a non-proportional relationship. Even though you have an initial fee and then you're paying $10 per month, this is still not a proportional relationship because you're paying this initial fee up front. So we do not have a proportional relationship, but we could still use an equation to represent this table. So it's non-proportional. But we could still create an equation because we know the cost per month. So y is going to equal the cost per month is $10, so 10x, because each month it's increasing by $10, plus the initial fee of $50. And here, if you substitute any number of months, so for example, 2 months, y is equal to 10 times 2 plus 50, we end up with y is equal to 20 plus 50, which is 70, which makes this statement true for 2 months. So if we substitute x for any number of months, we still get a true statement because we're paying an initial fee of $50, but we're also paying $10 a month after that initial fee. So even though it's non-proportional, we still could write an equation. So the difference between this proportional relationship is that here we have no initial value. We start at 0, 0, and there's a $20 cost per month for the membership. Here, even though we have a $10 membership cost per month, we had an initial fee of $50. In order for something to be proportional, it cannot have an initial fee. It has to be the same rate per month. So even though we don't have a proportional relationship here, we still have our rate of change, which is also known as our slope. And here 50 represents our initial value, which is also called our y-intercept, which we'll learn more about later on. So here we have another relationship, and this relationship is between the number of miles and the taxi charge. So the more miles the taxi drives, the higher the cost is going to be. So we notice that our x values here increase by 1. And our y values here increase by 3. So let's see if we have a proportional relationship. So after 0 miles, the charge is 0. There's no initial fee for this taxi to just get on. So after 1 mile, we're paying $3. So $3 a mile. After 2 miles, we're paying $6. So $6 for 2 miles. So for 3 miles, we're paying $9. So $9 for 3 miles. So for 4 miles, we're paying $12. So for 5 miles, we're paying $15. And for 6 miles, we're paying $18. So here, if we simplify our rates, $3 per mile is already simplified. That's our unit rate. So $6 for 2 miles, if we simplify that, we get $3 per mile. So those are equivalent. $9 for 3 miles ends up being $3 per mile. So that's equivalent as well. So $12 for 4 miles ends up simplifying to $3 per mile, making that rate also equivalent. $15 for 5 miles ends up simplifying to $3 per mile, making that equivalent. And $18 for 6 miles ends up simplifying to $3 per mile. So that's equivalent. So here all of our rates are equivalent, making this a proportional relationship. So let's represent this using an equation now. So y equals 3x because we're multiplying the number of miles by $3. And again, if we substitute x for any of these amounts, so let's say for 4 miles, 3 times 4 would equal 12, which is the cost represented by y. And remember that 3 is our constant of proportionality, our rate of change, and is also called our slope. All right, so we have our final example here, which is also a relationship between the number of miles and the taxi charge. So in our table here, we're increasing by 1 mile at a time. And our taxi charge is increasing by $2 at a time. And here, even though our taxi is charging us $2 per mile, we do have an initial charge of $3. So we could check to see if we have a proportional relationship. So 1 mile would cost $5, so $5 for 1 mile. 2 miles would cost $7, so $7 for 2 miles. 3 miles would cost $9, so $9 for 3 miles. 4 miles would cost $11, so $11 for 4 miles. And then 5 miles would cost $13. And finally, 6 miles would cost $15. All right, so here we have our unit rate, $5 per mile, so we don't need to simplify that. So $7 divided by 2 miles is $3.50 per mile. $9 divided by 3 miles is $3 per mile. 11 divided by 4 miles is $2.75 per mile. $13 divided by 5 miles ends up being $2.60 per mile. And $15 divided by 6 miles ends up being $2.50 per mile. So as we could see here, our rates are not equivalent. So this is not a proportional relationship. However, we could still come up with an equation to represent this relationship. So we know that the cost per mile is consistently increasing by $2. So y is going to equal 2x because our miles cost $2 each, plus our initial fee of $3. Okay, so even though this is not proportional because it has an initial value, we could still represent it using an equation. And remember that the 2 represents our rate of change and our slope, and the 3 represents our initial value, which is also called our y-intercept. And that's it.